Last final review video on statistics. So this problem might look familiar. You might have seen it on Khan Academy. So there's a problem like this with a variety of questions. You'll just see a few of those, if any, on the final. And then there's a question going over how to find the mean, median, and mode, as well as when you're given a table, how to find the different probabilities and the given statements. So if this is something that you need particular help with, you can always skip through the rest of it and watch that part. So this first problem says Nam owns a used car lot. He checked the odometers, so that's the mileage of the cars, and recorded how far they had driven. Then he created a histogram, so this one's a histogram, and a box plot that show the same data. So this data is the same exact data as this one, and this is measured in kilometers. So the thing about a histogram is that it shows you how many vehicles are within a certain range. A box plot actually shows you specific values. So it depends on what your question is asking to determine which one you should use. So A says which display should be used to find how many vehicles had driven more than 150,000 kilometers. So if you look at the box plot, more than 150,000, that would be all of these. But we don't know how many vehicles are in this range. So we want to look at the histogram. 150 starts here. So how many vehicles have more than 150 kilometers? That would be all of these, and those. So that's 6 vehicles plus 3 vehicles plus 2 is 11. So there's 11 vehicles, and we looked at the histogram to find that out. Which display can be used to find the median distance? So if you're thinking, oh, I can look here, I can just start crossing off 1, 2, 1, 2, cancel them out. You might find what the range is. So you might actually find that the median is in here or in here, I'm not entirely sure. But that only tells you a range of values. We're not looking for a range of values, we're looking for the actual distance, so the median distance. So this means we need to look at the box plot. If we look at the box plot, this value here is the median. So we can see this is 100, 120, 140, 160, 180, just kidding, 100 to 150, so it's 110, 120, 130, 140, 150, so this is at 140. And this was from looking at the box plot. So again, it depends on what the question is asking for which one you should refer to. Part C says, what is the minimum number of kilometers on a vehicle? And then what is the maximum? So if you look at the histogram, then you might think, okay, 0 to 50, that means there's a vehicle that has 0 miles on it. Well, that's actually not the case if you look at the box plot. The box plot shows you that this is the car with the least amount of mileage on it, and it's not at 0, it's at 10. So the minimum number of kilometers is actually 10. It's not 0 that you might think from here, it's 10. So, and then the maximum, again, if you looked at the histogram, you might think, okay, the maximum is 300. But again, this here shows you the exact maximum, and it looks like it's in between 280 and 290, so maybe around 285. I won't ask you one like that unless it's very clear what it's over. So I just want you to see that this is not a maximum of 300, it's actually a maximum of whatever this point is right there. So, and then part D says how many total vehicles are in the lot. So if you try to look at the box plot, we have no idea how many vehicles are made up. This could be 10 vehicles, this could be 100 vehicles, this could be 1,000 vehicles. If we look at the histogram though, we can count up the number of vehicles. So this is 3, 4, 5, 6, 3, and 2, just looking at how high up it is on the number of vehicles. So 3 plus 4 plus 5, that's 12, 18, 20, 23. So there's 23 vehicles. How many vehicles have between 100,000 and 200,000? So 100,000 to 200,000, that's all of these vehicles and these. So 5 plus 6, that's 11 vehicles. If we looked at the box plot, we could not figure out that information. Same thing with F. It says how many vehicles have less than 250,000. So 250,000 is here. That would be all of these vehicles up to this point. So you can count up each of those to find that it's 21. or you can take the total number of vehicles, 23, and just subtract out the 2 vehicles that have more than 250,000. So, yes, so for most of this we looked at the histogram, but to find the median and to find the minimum number and the maximum number, we looked at the box plot. So, on this last page, we've got a problem where we're given the data set. We need to find the mean, the arithmetic mean, that's just the mean. Right, as a non-reduced fraction, this is how I expect to see it written on the final. Also find the median and the mode. So to find the mean, we want to add up all of the terms. So add them all up and then divide by the number of terms. So this is 10 plus 8 plus 10 plus 4 plus 6 plus 7 plus 9 all over, and there's a total of 7 terms. So the mean, when you add those up, that's 54 over 7, and again, write it as a non-reduced fraction, so that's it. To find the median, make sure that you put the data in order of smallest to largest number. If you just keep it the way it is and you start crossing off numbers to find the median, you'd find the median is 4. The smallest number in this data set is 4. And there's a bunch of numbers higher than that, so there's no way that the median can be 4. So again, you got to put it in order first. That's 4, 6, 7, 8, 9, 10, 10, or another way you can do that is cross them off as you go. Make sure you've got them all. So the median, we've got 4 and 10, they cancel out, 6 and 10, 7 and 9, so the median is 8. And the mode is the number that occurs most frequently. The only number that occurs more than once is the number 10. So that's the mode. And then this last problem says the table below shows the results of a survey that asked students if they feel prepared for the Math 2 final. This is not a real survey that happened. It's just a problem to get you ready for the final. So more than likely, if you have been watching these videos or following along with Mr. Ferreira, then you are feeling more prepared. Anyway, so the first thing you want to do is look at the total in the columns and the rows. So the total of the column of yeses, we can add these up, 67 boys that said yes, 70 girls that said yes, it's 137. So there's a total of 137 students that said yes. And if you have trouble with these, you can go off to the side and write them out. So there's a total of 137 yeses. If we add up the no's, that is 63. There's a total of 63 students that said no. And then the total number of boys, this is 93. So boys, there's 93, and girls, there's 107. And when you add these up, 93 plus 107, that's 200. If we had added the yeses and the nos, we'd also get 200. There's a total of 200 students that were surveyed. And the nice thing about writing these off to the side is that you can use them to reference when you're coming up with the probabilities. So part B, it says a student is selected at random. What is the probability that this student said yes? So when it says a student is selected at random, that means we're just selecting a random student out of the 200 total students. So the number of students that said yes, so looking in the yes column, there's 137 students that said yes. We also found this number over here. So that's 137 out of 200. Again, write your answers as non-reduced fractions, so keep it like that. The total number of students that said no, there's 63 students that said no. So that's 63 out of 200 because it's at random. The total number of students, again, 200. And the likelihood that it's a boy. Well, if we look at the boy row, there's 93 total boys, so that's 93 out of 200. And again, we wrote that number here. And for girls, there's 107, and that's out of 200. Part C says, are the events saying yes to feeling prepared for the final and saying no to feeling prepared for the final mutually exclusive? So I'm just gonna recap on mutually exclusive because a lot of people seem to be confused on that still. So mutually exclusive means that two things cannot happen at the same time. For example, if we said, if you were to survey a group of people and they said, do you like ice cream? And the option is yes or no. So yes or no, there's no in between. There's no way to say yes and no at the same time to liking ice cream. So this would actually look like two separate circles. So there's no overlap. So yes or no to ice cream. This is mutually exclusive, which means they can't both happen at the same time. If instead you were to look at a survey as the number of days that it rained and the number of days that were sunny, yes, there's frequently days that it rains and there's no sun, or it's sunny and there's no rain, but there's also the possibility of it raining and it being sunny. So this is not mutually exclusive because they can both happen at the same time. So in terms of our data, we've got the yeses, yes to being prepared on the final, and the no's. And this is two separate circles. There's no overlap because it's one or the other. Both cannot happen at the same time. So this is yes, it is mutually exclusive. Again, if they cannot happen at the same time, then that means that it excludes that possibility. If they can happen at the same time, so it can rain and it can be sunny, then it's not mutually exclusive. And then this last section, be careful with these. So on the review for the statistics chapter, I had highlighted these or bolded these. They're not going to be reviewed, or they're not going to be highlighted anymore, especially on the final. So you've got to make sure you pay attention to those given statements. So if you're given something, that means that this is the new total. So this is going to be the bottom of the fraction. Given the student chosen as a boy. So we already know it's a boy. So we look at how many total boys are there. We said there's a total of 93 boys. So the bottom of this fraction is 93. There's a total of 93 boys. We want to know the probability that this boy said no to feeling prepared. We cannot go off of this no. This is the total number of no's. We know it's a boy, so it's got to be a boy. It's in this row. And we want to know that he said no. So a boy that said no, there's 26 of those. So that's 26 out of 93 boys said no. Given the student chosen is a girl, so there's a total of how many girls? We know that there's a total of 107 girls. We can also see that in the table. And we want to know the probability that this girl said no to feeling prepared for the final. So again, we cannot go off of this because this number of no's includes all of the boys and the girls that said no. We want to know just the girls that said no. So girls that said no, that's 37 out of 107 girls. Given the student said yes to feeling prepared, so the total number of students that said yes is 137. What is the probability if they said yes that they're a boy? So out of the 137, there's 67 boys that said yes. And given the student chosen said yes, so again, there's 137 total yeses. What is the probability that the student is a girl? So we're looking at the yeses that were girls. There's only 70 girls that said yes, so it's 70 out of 137. Good luck on the rest of the review assignment, and reach out if you have any questions. Thanks for watching.